most unprepared I've ever been for a video in my life. Today, I was sat in the class I was supposed to be teaching. I help out these underprivileged students who struggle with calculus. And this LARPer going to Cambridge called Archie low-key took over. And, I finished all of the problems very quickly. It was some, simple stuff like x squared e to the x dx. And, he didn't even teach them like just doing the standard DI method, even though it's accepted on the mark scheme. He made these poor souls use UV prime minus V, blah blah blah. He could, how much extra effort would it have been for Archie to teach these poor old souls the little DI method like this, you know? But anyway, he gave me this. He gave me this integral to do. He said, Noah, you're my favorite student in the class. You finished so quickly, and I'm gonna give you some advanced integral. Advanced in quotation marks, he called it. Thinking I would have never seen this problem before. The Gaussian integral. I mean, come on, Archie. What are you doing to me? Who do you think I am? Some kind of LARPer? Let's just say the big ox is at my door, not the big bridge. Anyway, obviously everyone's done this integral and their grandma before. And you normally do it using you can do it using Feynman, you can do it using a couple of methods. I've seen like Jacobian, I've seen these like partial derivatives and polar coordinates, all sort of stuff. It normally results in splitting the exponent up and then getting a double integral dx and dy. Okay? But we don't want to do that today. We're going to try and look at this from a complex analysis point of view. I've become quite partial to contour integration, and I want to see how it's applicable here. And first of all, I had the problem with the half plane. And normally you would construct a semicircle, right? But there was an issue, and I can't strictly remember what the issue would be. It's something like when you use e to the minus x squared, the complex function e to the minus z squared behaves differently in different directions of the complex plane, right? So if you rewrite z as r e to the I theta, then z squared is going to be r squared e to the 2 I theta. So e to the minus z squared is going to be go away, e to the minus r squared, why did I say it like that? Cos 2 theta plus I sine 2 theta. And then you can split the e up. You're going to get e to the minus r squared cos 2 theta, e to the minus r squared sine 2 theta. And the magnitude of the cos term, it's cos 2 theta. On some parts of the semicircle, you're going to see cos 2 theta is going to be less than 0. But so the integram would decay exponentially, right? But on other parts of cos 2 theta, it's going to be greater than 0. So it's going to grow exponentially. And for the standard upper half semicircle, you do it between 0 is less than theta, which is less than pi. And near theta is 0, you'd have decay. Near pi over 2, you'd have like massive growth. And then at pi, you'd have decay again. And in particular, at theta equals pi over 2, I think it will blow up like extremely fast to the point where e to the minus z squared is just going to be, sorry, that's an r, e to the minus r squared. So the arc integral over the large semicircle doesn't vanish as the radius goes to infinity, which is exactly what we normally want for contour. So, it doesn't really work. So the decay condition is because the magnitude you need cos 2 theta is greater than 0 on the arc, so a full upper semicircle wouldn't work. Um, so it's not like doing 1 over z squared plus 1 where the contribution goes to 0. It's because e to the minus x squared along the real axis and on the imaginary axis it explodes, but on the real axis it goes to 0. Anyway, I'm going off track. So what do we need to do is what you're asking me. Well, we can't use that f of z equals that. So we're going to use that f of z our complex function, equals e to the minus z squared over some other function, g of z. And we're going to find out what g of z is. And it's also going to be annoying. I'm very underprepared for this video, by the way. I, I have a rough idea of what I'm doing. I've got some of the math already written down in front of me, and that's about it. I know that some of our gammas are going to go to zero, and I'm going to have to evaluate them because I just literally said, oh, they'll go to zero probably. I know they do. Otherwise, it wouldn't work. But kind of got to prove that, right? So, our contour integral. Whoa. So we've just discussed we can't use a semicircle. So what we're actually going to do is use a box, a rectangle, if you must. So let's construct this over our real line. Yeah, that'll do. From and like I said, we're gonna make a rectangle. That's a parallelogram. It's more accurate. Now it's not. Uh, it's kind of there's gonna be shifts, but because you're doing it over infinity, it's fine. Like the I part does make it more of a parallelogram, but because it's over it's fine. It's fine. Don't worry about that. Let's make it simple for ourselves. Let's just assume a bunch of things and call it a day. So gamma 1. Nice. Now we're going to go up to some point R plus IB. Okay? And we're going to go along. Wrong way. Why can't I draw an arrow? Yeah. We're going along to this point minus R plus IB. And this is going to be gamma 2. And this is going to be gamma 3. And this is going to be gamma 4. And this is at the limit of R approaching infinity. Okay? So what is our contour integral now? Our contour integral is going to be the function f of t, f of z. Why the fuck did I say t? dz is the integral over gamma 1 plus the integral over gamma 2. Do I have to really write these out? Yeah, I kind of do for completeness sake. And we know that this equals 2 pi I times the sum of our residues using our beautiful little formula that was created by somebody. Oh, that would be. Oh, there's also going to be this like singularity. Cool. And what we want is let's look at the integral over gamma 1 and gamma 3, because we're assuming that integral of gamma 2 and gamma 4 go to 0. We'll work on that later, if I can be bothered, or we'll just say that they do. We want that the integral of gamma 1 plus the integral of gamma 3, assuming that the other two go to 0, which they do, equals 2 pi I times the sum of the residues of f of z. Really being close, Shanna. Cool. So let's write this out. What do we have? Well, we're going from minus r to r of gamma 1. So the integral between minus r and r of f of z dz. I love saying that. Plus the integral between r plus ib. Is it? Or are we going any? Yeah, no, it is. R plus ib to minus r plus ib of f of z dz. And this is going to be equal to. It's the same. We want to kind of like change the. Let's go like this and this and this minus the angle between minus r and r of f of z plus ib. Yeah. If we use that z equals z plus ib, I can't use z, can I? Because I'm using it. Let's say w equals z plus ib. right? Then f of w is going to be f of z plus ib. But w is a dummy variable, so we're just going to call it f of z plus ib. Cool. And then that allows for us to do this, because then we get rid of it from the limits and we bring it into. You see what's going on, you see the math, you understand the math, yeah. Well, is it a plus or is it a minus is the real question. What makes this right? Minus. I'm out by one minus. It's not like the last example I did where there was like four minuses. Okay, cool, cool, cool. So now, in the limit of our approaching infinity, well, we're just going to have the integral between minus infinity and infinity of f of z dz minus f of z plus ib. Yeah, because I think it's changed. Dz, and we know that equals 2 pi I times the sum of the residues. Is it going to be f of z now? Or is it going to be f of z plus? No, it's still going to be f of z. F of z. Nice, 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 nice. Cool. Okay. What next is the question. Well, well. We want that f of z. What do we want to say? We're going to say this minus what we just wrote out. No, too much math. Too much maths on my board. E to the minus z squared. We said there's a problem with that function. We're gonna need to introduce some like thing because it's not gonna work. We're gonna need to use. Let's use tau. Okay, instead of IB. So what we're gonna say is that because we need B to be complex, right? Um, we need B to be in the complex number, IB to be a complex number. And because IB is going to be complex, we can call it some other thing. And we're going to use tau. So we're going to use tau. So we want f of z minus f of z plus tau to be equal to e to the minus z squared. Nice. Yeah. That's all I wanted to do was get rid of the IB, which we've done. I should probably write out. Nah, it's fine. It's a fine. It's a fine. And now let's start working on this. F of z equals e to the minus z squared over g of z, as we said already. And let's do e to the minus z squared over g of z minus e to the minus, well, what are we going to have? We're going to have z plus tau squared. Um, that's a j, no? Squared. Whoa, what am I doing? I'm actually geeked. Squared over g of z plus tau. Oh, how is this going to help? Like, how is it actually going to help? It just looks annoying. So I've got to expand. And we're going to assume that g is periodic in tau. This is e to the minus z squared, as we've said before. Now, let's expand this bracket. I'm not going to fully write it out because I'm probably going to have to write it out 400 times. What is that? 2z tau? Oh, they're too similar. Why did I pick tau? V and then a tau minus tau squared over g of z. God. Which now we can split this up as two e's. E to the minus z squared and e to the minus 2z t tau minus tau squared. Oh, I'm writing t now. Should we use t? t equal. Yeah, my handwriting is too bad for this. And we know that this over g of z is e to the minus z squared. God, this is going to be a long fucking video. I should be more prepared. Why didn't I research this more? Okay, we can do some cancellation here now. Cancel, cancel, cancel. Nice. So we're left with that is going to be one. That's going to be one. That's going to be one. We're going to be g of z times it over because it's just one, and then there's a one left from here. So g of z is just going to be 1 minus e to the minus 2 z t. We're saying t minus t squared. Nice. Cool. That's helped out a lot. So, has it really though? Has it really? And now we want that g g is periodic in t. So g of z is going to be g of z plus t. So 1 minus e to the minus 2zt minus t squared is 1 minus, you put that in brackets. How does that help? Because you're going to get two exponential terms. And we're going to be left, we want that is going to be, okay, cool. Okay. I still don't know where this is going to go. I've still got to work so much out that I don't really want to do. Why did I do this fucking video? Archie, you're kind of grilling me. E to the minus 2zt minus t squared equal 1 minus e to the minus 2 logs of z plus t. Um, of t minus t squared, um, which is going to give us 1 minus e to the minus 2 zt minus t squared times e to the minus 2t squared, right? Okay. And we want the e to the minus 2t squared, the e to the minus, well, it's a complex number, we said. Squaring gives e to the 2 pi I k, where k is in the, so, oh, this is difficult. I should have prepared more notes on this. 2 pi I k. I watched a guy do it. Is that good enough? And then now I'm just doing it. If I come Instagram, about it. God. Next, let's just solve this. Let's just solve this. It's simple enough to solve. We can get t. That's what we're trying to do. Trying to isolate it. Let's just go. Let's do it. Come on, guys. Minus 2t squared equals 2 pi I k. We can solve this as t squared equals pi I k. So t equals square root of pi I k. Now, what k value should we pick? Well, can't be 0. That would be stupid. We're just gonna pick 1, let k equal 1. T equals square root pi I. Holy god. There's not much maths. I'm just fried. I did an economics exam today. Too much writing in my life. So now we can sub this in. Let me go here. G of z equals 1 minus e to the minus 2 z t e to the minus I pi. That is the same as minus 1. So that's just going to make this minus a plus. So g of z is going to be 1 plus e to the minus 2 z t. We've solved for t. Do we plug? Well, let's do our polls. Look, so it's just going to be when the denominator is 0. And what is that function again? Let me just write it out for the millionth time. E to the minus z squared. Oh wait, I'm gonna forget that now. Over 1 plus e to the minus 2 z. And so 1 plus e to the 2 minus 2 z t equals 0. E to the minus 2 z t equals 1. Does it, mate? Does it really, though? Minus 1. And so it's going to be odd. Like, we just do it for k now. 2k plus 1. So I pi plus 2k plus 1. And then we can simply say, now we can plug in what t was. We're going to get minus 2z. Oh, God. Square root pi I. This isn't nice, man, is it? Equals I pi 2k plus 1. So z is going to be. I'm going to put it back in terms of t because this isn't. Z equals t over 2? Yeah. Uh, 2k plus 1. Okay. 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 We got somewhere. Now, what one are we interested in? Let's just say like k equals 0. No, that's not right. We're only interested in. Let me have a look at it. It's gonna be like a straight line. It's 45 degrees. Because it's a quarter. Um, like that's just gonna be e to the I pi over 4. So it's 45 degrees, yeah. Um, so it cuts in like this. And then this point is just gonna be at t over 2. So we're only interested in t over 2. So we can just say z equals t over 2. And that's allowed. Cool. Now for the fun part, proving that gamma 2 and gamma 4 are 0. Oh, I really can't be bothered. I think what I'm it's just it's really so fiddly. I think what I'm gonna do is I'm gonna ask an AI to prove it for me and then write out what it does because uh, let me let's do it in silence. Um, let's talk about something as we do it. Let's talk about A level maths and how it's really boring. I was failing A level maths, not because I was terrible at maths, but because I found it really boring. And so last year, why am I using? Maybe I am failing maths. I just had like a terrible attendance. Because I was just kind of bored. I've always been good at maths. Like since I was a little kid, I've always been doing maths. I started working on well, I first discovered the harmonic series when I was like doing music and stuff because I loved maths then, and I came across the Euler Matrix constant, and it was fun. It seemed cool. It was like niche compared to I mean GCSE maths is a walk in the park. I say that I got a 7 there, which was really weird. Every paper I was doing, I was getting a 9 on, and I'm probably gonna get a C in A level maths as well. It's not even that it's hard. It's literally just like I don't know how to describe it. It's the basis of everything, and because of that, it's so tedious, and you don't want to sit there for ages doing like differential equations problems when you know you can do them. Like you know you can solve it. Like if you can sit there and work out the integral of something using complex analysis, then you can fucking solve a basic differential equation. But because of that, it makes you just not want to do it. Like it's almost like imagine you've been an accountant for like 20 years and then you're really good at it. And someone just asks you to like I don't even know, work out like simple profit or some shit. You'd be like unmotivated. Let me look for that. IDT. But yeah, and then what did the zero square root pi over two? Yeah, I think so. But anyway, yeah, it's like I didn't want to do it. But my econ exam by the way. I just want to get on to uni now. I'm taking a year off to do further maths and step and stuff, and then hopefully go to a math degree. Um, 'Cause this is the real fun stuff, right? I say that like I've not been complaining about doing it for the last 20 minutes. Um, what am I doing? 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 E to the minus. Give me 1 minute. E to the minus 2 is going to be R plus IT times T, right? R plus, oh my god, IT T, IDT. Absolute value of this, what is on my screen? Go away. Is going to be what's the interval between 0 and square root pi over 2? Ah, running out of space. E to the minus R squared minus 2RIT plus T squared over 1 minus E to the minus 2 T R plus IT dt. Oh, that needs to be split up actually, right? Like you just do the absolute value over the like that. No, it's not that much of a difference. Wait, shouldn't this be 1 minus this? Like 1 minus the minus of this, like a double minus? I don't know. I don't even know. And then that becomes the integral of e to the minus r squared plus t squared. Okay. Um, let's split that up if you want. Um, do I need to split that up? Not gonna become that though, is it? I was forgetting a denominator exists. I knew this would take all day to do this one part of the problem. 1 minus the absolute value e to the minus 2r e to the minus 2 pi it dt. Um, that is gonna be, well, fix the root. That's gonna be, what's the t squared? And then the t is gonna go to 0, and the e to the minus 2 over root pi over 2r, it's just gonna be 0. Proven, 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 proven. Um, proven. So yeah, cool. And then the integral of gamma 4 is going to be the same sort of shit. If you want to go do it, go do it. It's the same sort of thing. I'm gonna ask ChatGPT what it becomes. E to the minus r squared plus t squared over 1 minus e to the 2r e to the minus 2i plus 2it plus I. And e to the minus r squared plus t squared is going to go to 0, and the bottom term is going to go to infinity, so you have a 0 over infinity thing, so it just goes to 0. Cool. Right. So now we can just get on with our thing. The integral of gamma over 1 plus the integral of gamma 2 equals the integral between minus infinity and infinity of um, e to the minus x squared. Yep, that was our question. Which is going to be 2 pi I times the sum of all residues. And we're looking at the one at t equals pi over 2 times f of z dz. Now, it's going to be a limit. Probably have to use L'Hopital. 2 pi I limit z going to t over 2. And did I write pi over 2? Oh, dear. This should. I'm genuinely geek. This should say for the over 2. That's what we worked out, not pi over 2, did we? Of z minus t over 2 times e to the minus z squared over g of x 1 plus. I've actually got to check. 1 plus e to the minus 2z squared 2zt. E to the minus 2zt. Pretend that says 2zt. I know you can't really see. So yeah, we're gonna need to use L'Hopital. 2 pi I. It's gonna be split the limits up. Let's go for z t over 2 of z minus um t over 2 over 1 plus e to the minus 2z t. Okay, cool. Now just go here and let's say the limit z going to. Oh my god, my hand hurts. I haven't had to write this much for maths in like so long. E to the minus z squared. Now, differentiate a little bit chain rule. We're gonna get 1 over minus 2. What? 2z to the minus 2zt uh, times e to the minus e squared over 4. Which is going to be 2 pi I times. I literally just went to write pi again. I'm not even joking. Minus 2t e to the minus z. Right. So we're going to have 2 pi I e to the minus t squared over 4 over 2 pi I e. No, there's no pi's in this bit. 2t e to the minus 2t squared over 2. Cancel, cancel. We're gonna get minus pi I. So, over 2 e to the minus t squared over 4 divided by e to the minus t squared. Oh my god, we're getting somewhere. Yeah, actually getting somewhere. So, it's gonna be minus pi I over square root of pi I e to the 3t squared over 4 minus square root of pi I e to the I 3 over 4, 3 pi over 4. Which is just going to be minus the square root of pi times I, the square root of I, e to the I. So breaking up that, and then you're just going to get that it's going to be minus pi, or square root of pi, e to the I pi over 4. We've split it up, guys. We split it up. E to the minus 3 pi over 4. Oh my god. That's a 4. Which is just going to be minus root pi um, times minus 1. Times minus 1. Which is just going to be square root of pi. Yes. So we can say the integral between minus infinity and infinity of e to the minus x squared dx equals this one. Thank you, Archie, for the problem. Very good inspiration. I didn't really like doing the problem, but we've done the problem. So, yeah. Thanks for watching. Subscribe if you want to be better at maths than Dexter.